Can you see my screen again?
Yep, now we can see it.
Okay, great. We'll give it a couple more minutes before we get started.
Yep, I'm back. So stop my video.
All right, we'll give it a couple more minutes and we'll get started. I am recording this, just so you guys know. Hello, everyone. Wanted to welcome you to the ASCE seminar that we are putting on, the Utility and Engineering Surveying Seminar. I want everyone to know we are recording this. So the link for this will be posted on the section website and potentially on the website as well. Welcome everybody to this event. I wanted to thank Janet Fleming as hosting today's virtual event. A couple of really quick announcements. We do have a luncheon coming up on March 10th that will be virtual. We will be giving out our large and small project of the year, as well as the government engineer of the year awards at this event. So we look forward to all of you guys joining us, and PDA provided to the attendees for that event. PDHs are also going to be provided to those that are on the call today on this seminar. So that will be coming out in a couple of days from now. And want to go over just a couple of housekeeping items. We do have a question and answer forum for anybody that has questions during the presentation. If you can type in your question in there, we'll make sure that it gets answered at the end. I think it's being broken up into two separate sections, so we'll do question and answer after each section, and we'll get those questions answered for you guys. These are our wonderful presenters, and I will introduce Robert Ramsey, and he'll introduce the rest of the team. Robert is a vice president at T2, responsible for directing utility engineering and surveying services in the West. He's a registered professional engineer in 5 states and oversees subsurface utility engineering investigations. And his expertise includes providing SUE, utility design, survey, utility coordination, and project management services. And with that, I will turn it over to Robert.
I lost the, looks like we lost the presentation.
I think you need to share
There we
that.
go.
Okay, there you go.
Yep.
All right, so give me a second.
All right, we got it up. Well, thank you, Stephanie, for having us. Once again, my name is Robert Ramsey. I want to thank everyone for attending today's, webinar. We have a group of presenters, discussing utility engineering and surveying, and obviously the Utility Engineering and Surveying Institute of ASCE. So it's the UESI. I'm the current local Arizona chapter chair for UESI. I will get in a little bit more about what we're doing locally here in a minute, but I also want to introduce John Campbell is here with us today. John is going to talk about UESI a bit more on the national side. John is the current 2021 UESI national president. He's a founding member of UESI and a member governor of ASCE's Technical Region Board of Governors. We have Cesar Quiroga presenting on the 6 pillars of utility engineering, its effective approach to reduce delays and cost infrastructure projects. Cesar is a senior research engineer and manager for the utility engineering program at Texas A&M Transportation Institute. His research interests include optimization of project delivery processes, utility engineering, right-of-way acquisition, and impacts on transportation infrastructure. Then we also have Jim Monsbach discussing the new UESI education and certification program, as well as the updates of the ASCE 38 standard. Jim has over 40 years of experience, and expertise in developing and practicing subsurface utility engineering, utility coordination, and utility damage prevention. He is the chair of ASCE 38 and the founding governor and 2018 president of USI. So I want to thank all you guys for coming on today. We have some of the most technical people in the industry speaking, so I really appreciate you guys' time. Next slide. So for right now, as I discussed, the Arizona chapter of UESI is relatively new. We have a lot of key professionals collaborating and pushing to get the local branch up and running. Currently, we have myself, as I noted, as the current chair. We have Kent Groh as the chair-elect, and Ryan Kelly as the secretary treasurer. Overall, our main goals for our chapter coming out of the gate here is, basically to provide a forum to exchange technical and professional ideas with regards to utility engineering and surveying, identify and discuss technologies, different research papers, develop partnerships with organizations and to aid in education and training, and overall identify and reduce to manage the uncertainty in surveying and the utility infrastructure. With COVID, a lot of things have changed. Hopefully that's the short term, but our goal, as the local team, is to reach out, and this is underway right now with agencies, utility companies, consultants, the universities, and even contractors to get a solid, base and understanding what each group, has, what challenges they have, and what presents to each individual group. From there, we're looking at doing monthly webinars discussing different topics to meet the goals of the chapter by educating and identifying key elements and challenges that affect our individual state and our industry. Obviously, the national side is there, and everybody has different challenges. So we want to concentrate on what's affecting Arizona specifically, and how we can solve some of those riddles, if you will. Our first webinar is going to be conducted this next month by Sam Ariaratnam, ASU professor. It's going to be reducing damages to underground utilities during horizontal directional drilling. So keep a lookout for that invitation. And for everybody on here, if you're interested in joining the Institute, John's going to go in a little bit about that here in a second. Or if you have ideas on topics, you want to get involved, you want to learn about something, please reach out to me, the other board members. I would love to hear from you and get some of those ideas going so we can help, solve some of these problems that we have in our industry with the uncertainty of the utility infrastructure and surveying. So I appreciate it, but I'm going to turn it over to John Campbell.
All right. Thank you very much, Robert. I appreciate the introduction. Can you hear me all right?
Yes.
All right. Thank you very much. Well, my purpose today in addressing the Arizona chapter of UESI is to give you a quick overview of Utility Engineering and Surveying Institute, frame our purposes, our goals, and our strategy for delivering member value. Ultimately, that's what we're about, is developing member value. The chapters, the local chapters, play the most essential role in being the mechanism by which our volunteer community of practitioners, designers, academics, and researchers can all join in this conversation. Our real purpose is to lay out these goals, to promote the community, to develop the practice, and assure a professional standard of care is taken forward in this thing that we're calling utility engineering. Advance to the next slide, please, Cesar. This is our strategic plan, and it's relatively simple, but each and every portion and aspect of our strategic plan, our vision, involves that on the ground, that face-to-face, that one-on-one engagement that is absolutely essential from our community of practitioners in the chapters. So what we at the Utility Engineering and Survey Institute are about is advancing the technology, this rapidly evolving technology associated with utility risk management and condition assessment and damage prevention. We want to certify this practice. You know, this is a unique arena of the practice of civil engineering that brings into cooperative practice a wide range of diverse range of practitioners. We have, our community consists of practitioners that do utility investigations, designers, academics, and researchers. And it's really an arena of civil engineering that is in a high-speed growth mode due to the advancement of technology. Certifying that practice means that we want to bring the professional community into recognizing and being able to differentiate those practitioners that truly understand what is involved with this business as opposed to those that might just be tangentially involved. It's that standard of professional practice that really becomes the objective of us certifying utility engineering. And then finally, and most importantly, is to build that community of practitioners that are all involved in one of these many diverse aspects of utility engineering and surveying. This is an area of practice that I said is a specific arena that was recognized by the American Society of Civil Engineering as a unique arena of practice called utility engineering. If you'll advance to the next slide, please, Cesar. And this definition of utility engineering is what really gave the Utility Engineering and Surveying Institute its start. It was that recognition that that utility engineering is a unique specialty branch of civil engineering. And this lays out what our focus is. The most important part of this definition is that second paragraph and the interaction between utility infrastructure and other civil infrastructure. Utility engineering is unique because primary purpose of our business is to manage the risk that's associated with the unknowns, the vast range of unknowns associated with utilities and their interaction with each other, with other civil infrastructure. You know, the events of our recent weather event in Texas has really brought into dramatic focus the interconnected nature of utility systems and the extent to which we are daily dependent upon them functioning properly. That interdependence is not only our dependence upon these essential commodity services that we receive, but the interdependence of one utility on the other. We saw this essential frontline community of workers and volunteers that supports and sustain these systems really brought into focus as we confronted our winter storm event here in Texas last week. And it really did bring this point, this feature of UESI's charge and utility engineering by definition, the interdependence on those things. You know, when we lost power, that quickly led to difficulties with cell phone communications, as well as then our water systems began to not function properly or be able to deliver adequate capacity. So, you know, it was just a cascading effect of things that really brought home the fact, two things that were important to me. First of all, is how much we turn in these times when things don't go as planned. We turn immediately to one another. You know, no one's looking up the ladder for leadership to come out and give that type of relief. You look to your neighbors, you look to your families and your friends, and you look to assist one another. So it was the reality of how dependent we are upon things going as planned, and when they don't, just how dependent we become upon each other. And to me, that's a great analogy for the importance of our chapters to the proper functioning of the Utility Engineering and Surveying Institute, because we can ponder and we can develop and devise the advancement of this practice. But when it really comes down to you know, the rubber meeting the road, it's all about our volunteers that are at the chapter level, that are investing their own passion, their own purposes towards solving the immediate problems that become their priorities. Go to the next slide there, please, Cesar. And the Utility Engineering and Surveying Institute wouldn't be the UESI without an equal investment by engineering surveying. You know, the practices of civil engineering, the practice of professional land surveying have long been running along in parallel in you know, separate silos. But one of the most essential features of UESI is the fact that it's an integrated ability for utility engineering to incorporate the functions and the features and the professional practice of engineering surveying. Our business is about managing risk, the risk of uncertainty that's associated with the existence of utilities and the impacts that that existence and the unknown location of those utilities can have on most other infrastructure projects. So our efforts to locate and establish the condition of existing utilities becomes absolutely dependent upon accurate, precise location information provided by engineering survey. Go on to the next slide there, please, Cesar. This is the organizational outline of the UESI organization. As you can see, we're composed of 4 technical divisions that are at the bottom of this organizational chart. Our pipelines division and our survey and geomatics divisions pre-existed the Utility Engineering and Survey Institute. They were standalone divisions within the American Society of Civil Engineers and existed, quite frankly, for almost 100 years, each of them. So we started the Institute, which is to give a technical focus on this particular area of practice, already with a firm foundation that had been laid in ASCE by our pipelines division and by the survey and geomatics division. What became new and what really defined the necessity as determined by ASCE for an institute specific to it was the Utility Risk Management Division and the Utility Asset Management Division. Two very important areas of our ongoing and advancing work due to the technology that has evolved in the business of detecting and investigating utilities, and also then the sophisticated mechanisms by which to identify, manage those assets, and manage the condition of those interconnected systems of systems. You'll go on to the next chart there, Cesar. This is the current network of our UESI chapters across the country and in Canada. You can see that there our Arizona chapter, one of our fledgling chapters, is the only one that we have in Region 8 in the United States. So you guys are pioneers. We appreciate you being out there and taking up and spreading UESI in the western part of the United States, where the only other chapter out there right now is the Orange County one in California. I think we've got 16 established chapters, and if you go to the next slide, Cesar. We have about 13 additional chapters that are under development. So we're a relatively new organization. The Utility Engineering and Survey Institute was just established as the most recent of ASCE's 9 technical institutes. We were just established in concept in 2015, and we spent a couple of years on double secret probation and became a full-fledged institute of ASCE in 2017. Jim Onspach, who you're going to hear from later, was the founding member and one of the first presidents of UESI as we got our charter underway. Jim has had literally a career exploring this arena of utility risk management. If you'll go to the next slide, Cesar. I'll begin my transition to handing this presentation over to Cesar Quiroga. This is the information that we want you to be able to have and take away with you when you take this presentation after we're done today, to give you the information about how to contact us and how to follow UESI. But I will now prepare to turn the conversation over to Cesar Quiroga. Cesar is a fellow Texan with me. I've known Cesar for decades. I don't even want to try to guess how long it's been. But we both have joined in this same sort of passion for removing the uncertainty that's associated with existing utilities. We've combined on quite a bit of research over the years, and Cesar is now the leading utility engineering and surveying researcher for the Texas A&M University Texas Transportation Institute. So Cesar, happily hand it over to you now. And again, thank you all for allowing me to tell you a little bit about UESI, and thank you so much for your volunteer efforts at putting this Arizona chapter together.
Thank you, John. I really appreciate it. Just as a reminder for everybody, this whole presentation is going to be available later, and you can then see the corresponding hyperlinks. So with that, let me start my presentation titled 6 Pillars of Utility Engineering. What I'm going to be doing kind of is take you through this journey a little bit on how this concept evolved, and also to try to paint the first utility engineering, which John defined earlier, but also the pillars and how you can use this as a framework for a variety of applications. And just keep this in the back of your heads, because although utility engineering as a philosophical concept is very powerful, you really need something tangible to work with. And so we submit the notion that the pillars correspond to the very first step in that direction, right? So think of that, first of all, as a framework. Number two, let's say you are a project manager, you can use this framework to try to identify the areas of expertise so that you can manage your utility project successfully. And what's also really interesting is that each of those pillars can be defined in terms of application when you look at the process to deliver a project. So I'm going to be using an example of how that is done. Of course, we have only probably about 40 minutes or so it's not that we will be able to complete the presentation, but at least it's to give you an idea of what that is. Let me begin with the risks of not using utility engineering. And I think perhaps this is a captive audience, so to speak, so I don't need to have too much on it, but let me just highlight something that is kind of an interesting observation. This table you see here is the result of a survey that was conducted as part of an NCHRP project more than 20 years ago. But I think the trends are as valid today as they were 20 years ago and as they were 50 years ago. So this was a survey that was conducted with DOT officials, designers, mostly consultants, and also contractors. And they were presented with a series of options between 20 and 30 as to reasons that projects could get delayed. And as you can see, the top 2 reasons that across the board everybody agreed on was, number 1, delays in utility relocations, and number 2, different site conditions related to utility conflicts. So you can see that these two are very much what you find when you're in the construction phase. So part of what we're trying to do with utility engineering is address the risk of finding these problems during the construction, but much earlier, when you're still planning the project, when you're doing the preliminary engineering, and certainly when you're doing the design. Those are the top 2 reasons. going down the list here, I would like to highlight this one, delays in right-of-way acquisition, because that one, as it turns out, is one of the most common reasons projects are delayed, because frequently utility companies don't want to sit at the table unless the situation of the parcels needed for utility locations is resolved. So you see those two reasons, right? Utilities and right-of-way. And then the third one is the environmental process, which if you ask most people, they will tell you these are the top 3 reasons that projects are delayed. And all this survey does is really just to confirm those trends. But it's not just location, right? When you talk to a lot of people in this business, they will tell you, yes, because we don't know the location of the utilities, and that is certainly valid. And I would say that is perhaps one of the most important factors. But the reality is that there are many categories or dimensions of risk. Certainly, we have utility location and operational attributes. And so you could address this issue by finding out where the utilities are. That's utility investigations, and Jim is going to be talking about that a little bit later. But it's not limited to that. You need to think in terms of what are the structural characteristics and performance of the utility facility that you encounter, right? Particularly those that are underground. You also need to recognize that even if you don't affect anything structurally, you have the reality that utilities occupy a confined space within the right of way, and you need to understand that. The fourth category has to do with scheduling and timing. You may not have necessarily a conflict, or you may think you have addressed a conflict geographically, but if you forget the fact that you're talking about sequencing, either doing design or doing construction, that's a source of risk. Then you have construction practices, and I have actually a couple of pictures to show you a little bit later, comparing a good practice versus a bad practice. And finally, cost management, right? So this is sort of the constellation of risks. And so when we think about utility risks, don't forget, it's not just about locations, it's about all these other categories as well. So if we don't address utility issues early, there are many consequences that we have. Certainly during the preliminary design, we have that during the design phase. A lot of the impacts are felt during construction, but even after construction, we have that situation. Hit the wrong button, apologize. So just in the interest of time, I'm just going to touch base on the impacts during construction. So if you don't address issues early, you may find things like construction site disruptions, damage to utility installations, environmental corrective actions that weren't planned, unnecessary revocations, and at the end of the day, of course, delays and higher cost overruns. So this one is, of course, known by everybody, and there are many reasons this happens. You could be in a situation where, there was incorrect information about existing utilities, or maybe out of service lines that are not shown on plans. All of us are familiar with one call markings that are wrong or not visible. And finally, information that is not updated on project plans or one call records. So this is the first type of impact. Some of these installations fail or are hit, and some of them explode, like what you see here with this gas explosion, which of course is a risk to the health and safety of not just workers, but also the community, or people who live or have businesses in the immediate vicinity. You have the risk of release of dangerous explosive liquids and gases. So that's a very important element. And then we have the other ones. Perhaps in the interest of time, what I would like to do is to highlight something that is published every year. There is a report called the DIRT report. And this one is kind of an interesting report for a number of reasons. This is published by the organization and group that are in charge of doing damage prevention programs. One of the things that you may want to note here is this: the number of damages, which it was estimated that were sort of decreasing over the years as the awareness of damage prevention programs increased, hit a plateau around 2010 and has now begun to increase again. If you look at the latest report, which was published just a few weeks ago, which correspond or show 2019 records, you will see that the estimated number of events, close to 600,000, is the same that we had back in 2006. So something is clearly not working. Now, of course, there is a correlation between the amount of construction and damages, but the fact that we have damage prevention programs that show this increasing trend is, of course, a reason for concern. So something has to change, and I would argue that the best way to address this is by handling utility issues early during project delivery. It's not 48 hours prior to construction or prior to excavation. So anyway, those are the risks of not using utility engineering properly. We went through the definition of utility engineering, so perhaps in the interest of time, let me just go to the next, which is actually the pillars. So utility engineering as a concept is interesting, but it is only when you look at it from the standpoint of project management that you begin to understand what you need to have in place. So this is kind of a generic diagram, and I would like to suggest the notion that it is useful when you look at it from the point of view of a project manager. Obviously, if you specialize in any one of these pillars, your view of the utility process might change. And that is a valid view, but it is perhaps an incomplete view in the sense that you are not looking at it holistically. And even this diagram is not perfect, right? But at least it shows the main areas where we need to focus on. So utility engineering really is about, if you are a project manager, think of the group of people or consultants, if you're not going to be able to do that internally, that you need to have on board so that you have your utility project completed successfully. The first thing you need to have is someone or a group that knows how to do utility coordination. You need someone or a group that knows how to do utility investigations. You need someone or a group that knows how to identify not just the conflicts, but also the conflict resolution strategies that you need to have. And obviously someone or a group needs to design those strategies that were selected. The result of the design is a series of documents that will go into construction. So you need someone or a group that knows how to build these installations or protect in place measures, for example. And then you need someone or a group who knows how to manage those assets. And I'm including in this categorization the right-of-way, right? So it's not just about managing the utility assets, which of course is handled by utility companies, but also the right-of-way as an asset. All right, so let me go briefly through each of these groups, beginning with utility coordination. And for those of you who do utility coordination, you might recognize the first part of this, right, is techniques and procedures to provide effective coordination between project owners and utility stakeholders. And that's important, but it's not sufficient. A very important part of the job requirements for a utility coordinator has to do with the preparation and management of utility agreements. That is the contracts between the project owner and each individual utility stakeholder. And also the preparation and management of documentation that goes in bid packages, right? Which is a pretty big thing, particularly when you're dealing with utilities that are in the highway contract, in the case of highways, or any kind of provisions that you need to have that involve coordination between utility owners and contractors. So utility coordination is basically focusing on that. Utility investigations, as Jim will talk about later, involve the use of technologies to do a number of things, including detecting, identifying, and mapping existing utilities effectively. And not just that, is the integration of this information, including 3D and BIM, in all phases of project delivery. So that's what utility investigations is about. Then, of course, we recognize that utility investigations is really about a variety of methods. And in plain English, these are about utility records research, documenting visible utility facilities, using geophysical techniques that are appropriate for the conditions, local conditions and soil conditions and so on. And finally, exposing utility facilities. For those of you who are not familiar, there is a standard guideline, which is 3802. And we're going through the process to update it, and Jim is going to be talking about that. Perhaps one thing to note is the recommendation to begin conducting utility investigations much earlier than used to be the practice. Nationwide, it used to be common to do utility investigations when the project was about 60% design or even later. Unfortunately, that's still happening, but I think increasingly DOTs are listening to those recommendations that say, no, it's important to start utility investigations much earlier. This is not to suggest that this is each of the four methods that we just described. It's just to highlight that in general, utility investigations should be conducted earlier than has been the practice for decades now. So that's investigations. The next pillar is about utility conflict management. And this is about the application of techniques, protocols, and systems that use the avoid, minimize, and accommodate principle. This is about, in other words, trying to avoid utilities if you can, try to minimize the impact to those utilities if you can't avoid them altogether. And then finally, relocate them when you have to. And the idea here is to try to identify resolution strategies that are in the best interest of the project. In many cases, it might result in relocations. In some other cases, it might result in protect and place measures and so on. But the basic idea about this particular step is identifying those utility conflict resolution strategies. One thing to note is, what is a conflict? So traditionally, a lot of people understand a conflict as being that between a utility facility and a transportation design feature, and it's something tangible, right? That if you allow it to proceed into construction, that will result in a conflict. But it turns out that a conflict is not just that. You could have a conflict with a temporary feature or facing during construction. You could also have a utility facility that begins to be relocated to another location only to find there is another utility there. That's sort of the third type. But then you have this kind of catch-all type of conflict that could be related to utility accommodation statutes or regulations, special provisions, which may be at the project level, or for example, utility permits, and of course, safety or accessibility regulations. So it's all kinds. It's just to highlight that a utility conflict is not just the obvious, right? And by the way, the first one is the one that you normally can catch with software. You know, if you have used 3D design, you're very much aware of hard clash detections or soft clash detections, and normally those are associated with the first type of conflict, rarely with the other three. Just to highlight these conflicts, so this one, which is based on an actual project, by the way, this is a transmission tower. The road used to be here, this used to be the curb line, so the road is being, the alignment of the road is being changed. So obviously this, if allowed to stay, this transmission tower would be in the middle of the travel lane, so that is obviously a type 1. This one over here is a detention pond, and just for illustration purposes, you see this sanitary sewer here, and just because it is outside the excavation perimeter doesn't mean that you should ignore it, right? So it's just to highlight that there are things during construction that might affect your determination of whether something is a conflict or not. Here is one that is completely made up, but just imagine a situation where a water line is being relocated to this location and there is a gas line here. And then finally, which is actually the case in this particular project where several of these facilities were too shallow. So anyway, this is just to highlight that there are many types of conflicts and you should be aware of all of those different types. The other thing to consider is that to do utility conflict management is not enough to use a conflict matrix. You need a whole constellation of tools. I'm not going to go into the details of this because I think most of these are obvious. Perhaps the last one is a very important thing to consider is that utility conflict management is something that involves interaction with utility owners. And this picture tells the story completely, right? You may have your project manager, a designer, a utility company representative, even a surveyor. Utility conflict management is a team sport, it's not a solo sport. And of course, it's the use of tables, right? So in this case, I'm just showing a template. This one, as an example, is the one that TxDOT has recently implemented for use throughout the state, and every state DOT or every jurisdiction has a different template. All right, so that's utility conflict management. A number of strategies have been identified as the resolution strategies. Could be relocation, could be protect in place, could be avoid, and so on. In this case, utility design is about the use of techniques and procedures that lead to more effective practices to design these things, these measures, including the preparation of plan specifications, schedule, and cost estimate. This is a critical thing. And just to illustrate what I'm talking about here, is not enough just to say, okay, we're going to relocate a facility or this one is going to remain in place, is to produce what is called robust utility plans, construction schedules, and cost estimates. By the way, on this note, the Federal Highway Administration has recently recognized the need of this, the need for this, and has actually come up with training and some checklists that provide people with guidance as to how to consider whether a set of plans can be considered robust. This is an example of construction schedules. It used to be typical just to use, have activities and durations, but the power of these schedules really become evident when you convert this into Gantt charts for individual utility companies, and also when you integrate these schedules with the overall project schedule. So that was utility design. Of course, utility construction is the next phase, and it's about not just the construction activity per se, but it's also about monitoring, inspecting, and serving utility installations at the job site, as well as mapping and producing quality standards-based utility as-built. And that one is a very big one. Of course, we have requirements to comply with, OSHA requirements, stormwater, pollution prevention programs, and so on. But it's about inspection and verification. It's about the preparation of as-built plans. So I told you earlier that I was going to show you two pictures, and both pictures are very telling. So the picture on the left is one of the reasons I like that picture is because you see everything. You see right here these workers finalizing the installation of this electric transmission duct bank. Then here is this guy in the back collecting as-built locations, and then right behind this individual you see the backfill already taking place. You see, the excavation, all of that. And by comparison, look at this excavation site on the right. You see this hanging gas line, which just is a clear demonstration of a poor construction practice. So that's about construction. And then the last one is about utility asset management. This is about techniques and procedures for not just accommodating and permitting and managing, but it's also about documenting everything that happens, not just utility facilities, but also the right-of-way over the entire life cycle. And if we want to express this in a slightly different way, this would be about managing utility data from the very beginning throughout the lifetime of whatever it is that we're talking about. So if we're talking about a project, it would be from planning to construction and the end of construction. If it is during the lifetime of the facility, it would be related to the permitting. And if you notice here, and this is more of a conceptual diagram, of course, I realize, but the idea here is that every time you have a product of some activity, in this case, utility investigations, think of it as interacting with a utility data repository. You do utility conflict management, likewise, utility design, and then what you have in practice is that you should have the capability to go back, for example, and conduct additional utility investigations if needed. So it is a process, and at the end of the day, you should have a product in the form of as-built that you can use for future management. All right, let me transition here to try to illustrate how the 6 pillars of utility engineering can function. And I'm going to be brief in this presentation and kind of look at it from a high-level project management perspective. It's only to illustrate that utility engineering doesn't really happen in the vacuum. It's really part of what we call the project delivery process. What you see here on the screen is a generic depiction of the process to deliver a highway project, right? So you have planning phase. The outcome of this phase is a decision to begin developing a project. Normally there is a scoping document there that is produced. But before that, we don't really have a project. It is really the decision to start developing a project that happens at this point. Then we have a preliminary design phase where we have, depending on the type of project, we may have alternative analysis. Not everybody has this, depending on the size, but you might have value engineering. In any case, you might have schematics. This is the phase where you do the environmental review, or at least when you should do it. The decision of this, pending the approval of the environmental process, is to proceed into the final design phase where you actually complete the design, you do the PS&E assembly, and after that you have letting, you have construction, and you have post-construction. Well, when you look at the diagram like this, you realize, let's say in the case of right-of-way acquisition, because all of them are closely tied. In this preliminary phase, you might have the development of the right-of-way plans, perhaps not finalized, and at the conclusion or after the environmental approval is issued, then you complete the plans and you begin the right-of-way acquisition. Here you have the utility process, right? And I would argue that the utility process really should start very early, right? Even when you don't have a project yet. But it's the idea that you begin coordination early. It's not that you're going to be doing utility investigations at this point. You're not going to be identifying conflicts at this point. It's too early. But you would begin the conversations and the coordination with the utility industry. And then on the other end, of course, you would like to finish everything related to utilities early during construction. The reality is, particularly in the case of reimbursable utility locations, that you still need to deal with payments and reimbursements and all of that. This is something that you would like to try to minimize, but that's why I'm showing it here in dotted line as a recognition that you might still have a few things to do after the construction ends. The last thing that I would like to call your attention to is this process bar right here. And the 30% is this reference point. The Federal Highway Administration recommends states to use 30% as the transition from preliminary design to final design. It really varies a lot. There are states that officially go 30% as the transition. There are many other states that consider this an aspirational goal more than anything else. And then they transition to design probably when they are about 60% design. Same thing with the environmental process, but this is just a reference element. So using this one as a framework, let's see what happens with the various phases that we have. Of course, we have the 2 milestones that I mentioned. And the idea here is that you have utility engineering as a series of activities that you undertake throughout project delivery. So I call them UE 1 through 6. It doesn't mean that every project has all 6, but as an example, let's see what happens with UE 1. Remember, here you don't have a project yet, but I would argue that there are a number of things you could do at this point. You don't do utility investigations, but at this point, you should start identifying major utility-related issues that might affect the project scope. And how do you do that? Well, you could meet with utility owners about the planned project. Some DOTs have regular utility coordination meetings, maybe once a year, maybe every other year, or 6 months, whatever the frequency. But the idea here is that this is a great opportunity for DOT folks, for project owners, to identify major plans by the utility industry and vice versa. Then you go to the preliminary design phase. The project has started, the development has started, the environmental process is undergoing. And at this point, you could start doing a number of things. You should definitely, don't wait. At this point, you should notify utility owners that there is a proposed construction project that might affect them. At this point, it is really the best time to start doing utility records research, if nothing else, and begin to identify major physical constraints associated with utility facilities. And definitely start assessing utility impacts. At this point, don't expect to have major decisions as far as what needs to be relocated. It is perhaps too early, but at least you can start conducting these activities early on. Then you go toward the end of this preliminary design phase, and at this point, you should have a pretty good idea of what the horizontal alignment is, and some information about the vertical. And hopefully the environmental process has been finished or is very close to reaching a conclusion point. And at this point, you should be doing a number of things. Definitely, in parallel, in parallel to the project survey, you should be doing a survey of above ground utility facilities. If you can, and this is an increasing recommendation, begin to use geophysical techniques to achieve a quadruple B. Correlate this with the information that you had before. Identify conflicts, right? This would be the first time that it would be popular in the utility conflict list. And talk to utilities, meet with utilities to identify these conflict locations, assess constructability challenges that might affect the final alignment of your project, and discuss potential resolution strategies. Then the goal here is to try to identify those major conflicts primarily. Don't focus too much on the minutia, but this is where if you have an opportunity to realize benefits, this would be the best time to do it. Then you go into the design phase, and then of course you have more detailed information. Definitely, if you haven't done a geophysical investigation, you have to do it at this point. At this point, it becomes strategic to expose utilities at specific locations as the test holes that you would be doing. Increasingly, we have seen these also during the preliminary engineering phase, but the case is not always very clear. But at this point, definitely yes. At this point, you would be focusing your work on analyzing conflicts, trying to see if you can avoid utilities, minimize the conflicts. And who knows, maybe at this point you can start working on utility location plans. If you have done the work correctly and the information is sufficient, there is really no reason why you couldn't start doing this. In some instances, although it's still kind of early, remember we're between 30 and 60%, but some utility companies might decide to start utility relocations. And so the idea here is to monitor this so you can develop as-built plans from that information. Then toward the end of the design, at this point, honestly, you shouldn't be doing utility investigations, although we'll still see projects where utility investigations start at 90% design. This is really not the time to do it. You should have done that much earlier. Continue utility coordination activities, refine schedules. This is a very critical point here because you are finalizing the PSME phase, and you need, as part of the project, you need to develop the engineer estimate and also the engineer schedule. So you need to have a very clear understanding of what utility companies can commit to, and not just have that conversation with the utility owners, but also with the other stakeholders, including designers and so on. The last part here is including, develop this document, which is called a utility statement according to the Code of Federal Regulations. States call it in many different ways, certification or document, whatever. But the idea here is that you develop a document that summarizes what has been done so far, what utilities are not in conflict with the project, and any utility work that must be completed during construction. And then finally, during the construction phase, it's not that you all of a sudden don't have any more problems, but clearly if you have done the work correctly, the number of issues that you have during construction should be much lower than if you hadn't done it this way. We have seen a number of state DOTs beginning or conducting what is called pre-construction utility coordination meetings, which are different from the normal pre-construction meetings. Yeah, they can be conducted as part of the same session, but really for some big projects, it's a good idea to have these separate pre-construction utility coordination meetings, and definitely continue the coordination during construction. Use the escalation process to identify conflicts and resolution strategies quickly. And of course, you have to update those utility relocation schedules. All right, so kind of in closing, I'm reaching the end here, but it's just to highlight what these 6 areas of expertise are. Jim is going to be talking about certification, but I would like just to highlight that there is a need for us as a community of practice to develop training materials in all of these areas. Certainly, utility coordination. If you look at the National Highway Institute, there are some very short, like 2-hour long, typically, web-based courses. There is one course on utility coordination that, quite frankly, needs to be updated. Here at TTI, we're developing a utility coordination course. It's 2 days so far, and I think we're going to build it up into a 5-day course. Utility investigations. Jim has been teaching the utility investigation school. There is a huge need for this. Utility conflict management. At TTI, we have been teaching a 1-day utility conflict management course, which again, we are building into a 5-day course. Utility design. If you are an engineer, you are probably familiar with formal training programs at universities, but they tend to focus on individual classes of utilities. So if you want to learn how to design pipelines, well, you go to the civil engineering department and take courses, either at the undergraduate level, some, or graduate level, more frequently. Likewise, if you want to know how to design a communication network or electric network and so on, what is needed is design courses that focus on the whole utility network as a holistic practice. John talked about the interdependencies that became painfully aware for their lack of management last week in Texas. And that is something that is badly needed. Construction, likewise, many courses are available at the university level on construction management. But I would also argue that there is a need for more awareness in terms of how to manage all those utility infrastructure or utility facilities that you might encounter during construction. And an area that is honestly missing completely in any kind of formal or informal program is that one related to utility asset management. Again, if you are a member of a utility company, you probably have training and there are software packages that allow you to manage your network, but holistically, there is a need to develop not just awareness, but programs that highlight the management of the right-of-way and the utilities that occupy that right-of-way in a more holistic manner. Okay, and I think that's about it. So here's my contact information in case anyone has any questions. This one is going to be available later, but if you have questions, certainly. And at this point, I don't know if anyone has any questions or comments.
We do a couple of questions, Cesar.
Sure.
What about utility access planning? Who should do this, and must it be accounted for early as well?
I'd like to make sure that I understand what the question was about. Is it access as in access to the right of way, or what specifically? Maybe
Maintenance.
someone could just unmute yourself and maybe just elaborate a little bit. Because I wonder if this is related to permitting, but I just want to make sure that I understand the question.
He's asking about utility access planning and maintenance.
Oh, I think the question then is related how to access utility facilities. I believe that's probably what the question is. And it can be looked at from many points of view. Certainly when you're doing coordination, that is a common question because utility companies would like to make sure that when, not just during the planning phases and design and construction, but certainly after, that the issue of how to access the facilities becomes addressed. It has to do with utility accommodation as well because the managers of the right-of-way, and I'm thinking highway right now, they are interested in making sure that access to the road is allowed. But if you occupy a part of the roadside, then the question is, how do you access as a utility owner? How do you access your facility from, say, the road? And that is a common question when you're dealing with utility accommodation practices. And it depends. If it is a pole, well, you have certain requirements. If it is a communication duct bank, you have other requirements and so on. So it kind of changes. I can tell you, though, that every state DOT has utility accommodation rules, typically codified in the form of an administrative code. And at least here in Texas, and I believe the same practice occurs throughout the country, it is the DOT, the one that manages that. And you will see a whole set of requirements as to what is allowed and what is not allowed, of course, from a transportation perspective. But you will see requirements related to longitudinal installations, to crossings. And these requirements include not just the horizontal alignment, but also the vertical. And so that's a huge requirement. If it is crossings, then you have to deal with not just the depth of cover, but also things like encasement. And that varies quite a lot.
Okay.
I'm afraid I haven't really answered the question properly, but I'm afraid that that's the best I can do given the limited time we have.
Sure. Your presentation focused a lot on transportation projects. Will these also apply to proposed water lines, sanitary lines, etc.?
I really like this question, and the reason is yes. How do I know this? Well, perhaps something that was not highlighted at the beginning of the presentation was what I did in a previous life. I'm a civil engineer, and I spent more than 10 years designing waterworks, pipelines, channels, and so on and so forth. So I was looking at the issue with utilities from the standpoint of developing those projects. And at the end of the day, it's actually very similar because you're dealing with a right-of-way, which is the right-of-way you need for your project. And your project could be a road, could be a railroad, could be an airport, could be a port. And the interaction with utilities is actually very similar. And you will face similar challenges that you don't know, first of all, where those utility facilities are. No one teaches you how to interact with those utilities. The issue of accommodation is also practical because you need to know where those utilities are so that you know where to place them if you need to move them. But also how to design your project without affecting those utility installations a lot because let's face it, utility facilities occupy rights of way, and that accommodation has been enshrined in codes throughout the country since the 1800s. the second part of the 19th century is when the concept of accommodating utilities within public rights of way evolved. So it's a long history. So I would say not just water, but also pipelines. Any kind of infrastructure project would have similar issues.
Do you know if UESI or if there's any coordination with the NCHRP Synthesis 506 for effective utility coordination?
Yeah, I would say so. Several of us are very much engaged with the NCHRP through TRB, of course, through the Utilities Committee. Some of us have worked either as principal investigators or as research staff, and I can point to most of the speakers in today's session. We have a similar experience. Yeah, so it's not just 506, but there are other NCHRP products that speak to the need to improve utility coordination practices. There are also some products on utility investigations. Utility conflict management, although I didn't touch base on this, but it was one of the products of a companion program, which was the Strategic Highway Research Program, the second, SHARP 2. I don't think that NCHRP or any of the TRP programs has focused much on utility design, construction, or utility asset management. I think there is one SHARP 2 project that worked on that, maybe a couple, but not too much. There is some state research that has worked on utility asset management, but we need to do much more.
There's a question on what is the UES fee compared to the construction costs? Is there a percentage based off of that?
I'm sorry, I missed the question. Could you repeat it?
What is the UES fee compared to the construction cost overall? 1%, something like that?
Oh, yeah, gosh. Actually, that's a great question for a number of reasons. One, because there is really not a set fee or percentage. And if I understand the question correctly, it has to do with let's say you have an infrastructure project that is about $100 million. What would be the expected utility cost? And there is not a set percentage. What we do know is that there is some correlation depending on the kind of project, and the correlation is better defined the more linear the project is as opposed to a local project. So if you have a project like an interchange, for example, it's pretty difficult to develop a correlation between the utility cost and the size of the project because it's much more linear. It's much more localized. The longer the project is, it is a little easier to do that. There are no good statistics, and there are several reasons for that. One is that project owners frequently don't have a good idea of what the cost to relocate utilities is. One of the reasons is the structure that is normally used to develop utility relocation costs. So that's one. We do know that depending on the type of project, percentages could vary from 1% to 10% to 20%. Usually the smaller the project, the percentage is higher, but that's as far as I can go. I think someone made a comment here in the chat. Did our own utility coordination? Okay, no. Sorry, completely different question.
No worries.
And I think the question was so it's utility engineering. That's the other one. I honestly don't know. I do know more in terms of the savings if you use or if you apply all these principles, but in terms of the actual fee, no, I don't have that. All right, maybe John or Jim might care to comment.
Oh, they want
State
to
the
jump
question
in.
again, please.
Is there any associated cost with the UES component compared to the overall construction costs? Whether it's 1% of the overall construction cost, 2%.
Yeah, well, it depends what you mean by UES. If you're talking about the investigation portion, there have been studies for transportation projects and water and some water projects that were done under design build contracts, and they generally range about 1% of construction costs. But that's just the investigation portion. That's not any of the utility coordination or utility construction, the as constructed, surveys of that. All of that is different. So every project is different, but I'd say a range of 0.5% to several percent is probably for a typical infrastructure project not out of line.
And I'm trying to remember right now, because a couple of years ago, somebody asked me that question and I looked it up, but I haven't done that since, but I seem to remember looking at some projects for which they assumed percentage of utilities was like 1% of the total project. And I immediately saw these people are going to have problems later, because it looks like they are severely underestimating the costs related to utility locations and other things.
And this is Robert. I also wanted to highlight it also comes in of what the cost is, but then there's a lot of those studies that Jim has mentioned and Cesar mentioned have talked about different cost components. So say it's 1.5 or 2%, but they also discuss what the overall cost savings were, and a lot of those are upwards in the 20-25% in the cost savings during construction. So it kind of run both of those together when you're looking at what your cost and your risk mitigation is for each one of the projects and how much you're projected to save on the back end.
Yeah.
Are you recommending that the consultants help create scheduling or sequence requirements to be put into the construction documents? And do you ever see issues with that dictating type of means and methods?
Okay, so could you repeat the first part of the question? Are you talking about the consultant engineer, the design engineer, or the utility engineer?
The consultant, I'm assuming, is the design engineer in this instance. Are you recommending that they help create the scheduling and sequence requirements to be put into the construction documents?
Oh, absolutely. Absolutely, because that is actually one of their recommendations. If you look at PS&E, right, is plan specifications and estimate. What a lot of people don't see in there is the schedule. And the schedule is an integral component of the bidding package. And so a lot of times what happens with the design consultant is they develop the engineer's schedule, and everybody agrees on that, and then the contractor that is selected looks at it, and then they start making changes. For our conversation here, I think what's also important is to recognize the degree to which utility schedules might impact those engineering schedules and the construction schedule. And if you recall one of the slides, I talked about integrating, not just developing better schedules for utilities, but also integrating those schedules into the overall project schedules. Because when you do that, you start to see the interdependencies, right? For example, let's say that a utility company needs to finish a utility location, but in order for them to finish that utility location, a detour road needs to be built as part of the highway project, right? I'm talking about highways here. And so obviously the utility company is not going to build that detour, right? The contractor has to build it. And that coordination needs to be clearly spelled out on the construction schedule. So that's an example where a utility company needs information from the contractor to finish their job. But vice versa is also true, right? So imagine a temporary pole or even an electric pole that is sitting in the middle of the construction area. And for the highway contractor to finish their job, they need that utility pole to be relocated. That's an example where the contractor needs an action by the utility company to proceed with their construction. So yes, in short, yes, definitely, that's something that needs to be that needs to be done. The Federal Highway Administration finally recognized, I think some 5 years ago, that there is a need to improve scheduling activities because of the issues with utilities. And one of the ways to do that is to make utility relocation schedules more robust, and also to integrate those schedules with the overall project schedule.
Do you recommend having a written report on the existing utilities prior to design?
This is a question for Jim, actually, I think, because I think if I understand the question correctly, is let's say you do a utility investigation using ASCE 3802. You submit a set of plans, right, with the existing utilities. The ASCE 3802 does not include a requirement for a utility report, but the new version of the standard will have that. And just like you have a geotechnical investigation where you have a report that is signed and sealed by an engineer, the idea is the same, where you could document the process that was followed, the equipment that was used, the assumptions that were made, any issues that were found and how they were resolved.
I think to add to that, both the investigation of utilities, whether we are putting information on a utility drawing or in a report, it's an iterative process. And just like we have a revision block on a set of plans saying, hey, we changed something on this date, we're going to have the same kind of revision block in any kind of written report or utility drawing to make sure that it's up to date with the current state of the design. So yes, we do recommend moving forward that there be a utility report. When that is sequenced during design and how much of it is included depends a lot upon the status of the utility investigation scope of work. So I guess that's a more complete answer is yes, we want one. And will it happen before design? Well, maybe some aspects of it might happen before design, such as saying these are the utility owners that have known facilities within the project limits. That could start immediately, and you could issue a report on that and add to it over time as you get more information.
That's a good point, Jim. And kind of to further expand on that, you have, of course, the outputs of the design activity, which are all engineering documents. And you have the investigations, including the report that Jim elaborated on, but also conflict management, right? The idea here is that one of the products, which is a tool as well, is the utility conflict list. Well, the structure of these tables has evolved over the years, and now we have a concept where the table is really a series of tools within the table structure that enables you not just to identify the conflicts, to identify the resolution strategies, but enables you also to tell the story later. So that if, for whatever reason, there are questions about how a specific conflict was identified and how it was resolved, you'll be able to see enough information so you can tell the story. So there is not a requirement or even a recommendation to sign and seal the utility conflict list, but it's just to highlight that when people use it in this fashion, they really turn that document, which is a very dry table, into an engineering level document.
One more question, and then we'll take a second for Jim to get set up on his. As a consulting engineering firm, say decide to hire a UES as a sub to assist with the project, but there ends up being a conflicting issue with utilities during construction. Have you seen that would typically fall on the UES sub to be responsible for that? Or would that still be part of the whole consulting engineering design?
I guess this is like opening Pandora's box, I think, because first of all, it really depends on what the scope of work was. And let me give you a simple example, and then perhaps others might want to pitch in. If a common thing that I've seen is this. Let's say that a SUE firm is hired to do a utility investigation, right? But then the project owner believes that they are also responsible for identifying conflicts. And then the SUE provider does what they were hired to do, and then there is a problem that is found during construction. Well, whose fault was it? Was it the suit provider or was it the project owner because they didn't use that information properly? Um, so it really depends a lot on the scope of work. Um,
Well,
and-
actually, let me expand on that. It's really a matter of contract law. And EJCDC has that very well set out, as does AIA and other contract mechanisms. But the prime, the project owner doesn't have a contract with each of the sub-consultants for the prime designer. The prime designer holds that. So the prime designer is on the hook. Now, the sub-consultant that works for the prime designer, they of course have a contractual relationship and they have to figure out amongst themselves who caused the problem and who's going to solve the problem, whether it be extra work or a claim settlement. So it's actually it's a pretty easy question to answer. It is the prime consultant's responsibility to hire a sub-consultant that they are comfortable with, that is insured to the levels that they need, and hold them responsible for negligent errors or omissions on the product that they supplied as part of the design function.
Yeah, that's actually a very good way to explain it. We have also seen some wrinkles where the project owner retains certain activities, for example, right-of-way acquisition. And so the finger pointing happens later because the project owner might be blaming the design consultant for problems that happen during construction, when in reality it can be traced back to things that the project owner didn't do, even though there was a prime consultant with overall responsibility for the project. But there were some things that weren't hired, that the consultant wasn't hired to do.
That's all that we have right now for questions. So if we want to take a quick minute or so break, get Jim set up, and then we'll keep going with the next portion of the presentation. Jim, whenever you're ready.
Okay, are you seeing the correct screen, first of all?
I am seeing your slides.
Okay. All right, I'm ready to roll. Hi, I'm Jim Onspach, and today I'm going to talk about the UESI Education and Certification Program, along with a brief snapshot of those changes that are anticipated for ASCE 38, which is in ballot right now. So those changes are coming quickly, and that standard should go to public comment shortly. So universities have long focused on aspects of civil engineering that cover a majority of the 6 pillars that Setzer talked about. Pipeline and utility plant planning and design, utility asset management, construction engineering, obviously, and engineering survey are examples of courses that are being taught right now in different universities across the world, really. And most people in that civil engineering curriculum intend to practice as a professional at some point in their career, applying for their PE license, but not always the time. And getting that license is a rigorous process, right? We know it involves coursework, testing, examples of practical experience to demonstrate proficiency. But the field of civil engineering is broad. and few, if any, engineers are proficient in everything. That's why we have that caveat in every state licensing statute that states that a professional must be proficient in a particular subject area in order to practice in it. There's a lot of discretion left up to the professional in regards to their self-evaluation of that proficiency. University courses and examples of work or projects that you worked on are logical places to look for that proficiency. The American Society of Civil Engineers actually put out a policy statement, number 535, that says and recognizes that, that the process of designing a project, it requires a team of professionals and technologists and technicians. And those four groups have been well defined by ASCE and other organizations, whether it be ABET or NCEES, but they're out there. And so we've got this civil engineering team that we need to look at what are their education requirements, what is their education actual courses that they attended, and are they proficient in them? So two of these pillars that Setzer talked about have very few, if any, formal university courses. There may be some formal on-the-job training once somebody's employed, and even the rare 1 to 40-hour seminar like this one, or short courses that might touch on the subjects. There's certainly no recognized certification program for either utility investigations or utility coordination. In the last century, this wasn't a big deal because most state DOTs and utility owners did all of these functions in-house, rarely using consultants. Design engineers basically abdicated any responsibility to do a utility investigation to the contractor during construction, and utility coordination was performed at the last minute before construction or even during construction. Lots of factors changed the way we looked at utility issues on projects, from case law to right sizing. Sometimes in the early days, we called it capsizing of DOTs and utilities, to innovation by the private sector, to different contracting methods and good government policies by regulators. So nowadays, let's face it, identifying and resolving utility issues are part of the design team's effort, much more so than the contractor's efforts. In many populated areas, transportation projects are really more utility relocation projects, and the amount of knowledge and skills needed to cope with this is sometimes more complicated than the actual civil project design that's taking place. So the Utility Engineering and Surveying Institute, in partnership with other entities, has begun to look at those educational opportunities, specific knowledge sets, and potential accreditations or certifications for that engineering team, the professionals, the technologists, and the technicians that are needed for today's and tomorrow's complex, vital, and challenging issues regarding existing and planned utilities. So we put together a certification exploration group with a diverse range of stakeholders. And you can see them on the screen here. We had the FHWA, we had AASHTO, we had the Transportation Research Council, we have various academic members and some practitioners in there, along with some UESI, the USI director, I guess. So you can see that we've got a wide range of interests for projects. Yes, many of them are geared towards transportation, but that's only because our transportation rights of way have really become the pathways for our utility rights of way. In actuality, these certifications will work for any type of project in the future. So the group developed some starting goals for this certification program. One, we wanted to make infrastructure project delivery more efficient by providing owners with people that were certified in a particular task. Right now, you kind of have to take somebody's word for it on an RFP response or a letter or something, and that's you're taking a risk, right? You don't know if they're actually telling you the truth or they exaggerated it or not. We wanted to make certified utility risk personnel more valuable to their employers. You know, let's pay people what the value is of their knowledge and worth to the project. We wanted to give some measure of portability of recognized competency to employees' resumes. So the individual person, whether they're a technician or a technologist or an engineer, you know, might have some competency, but if they're looking for a new job, does a prospective employer really know what their capabilities are or not? So we wanted to give that portability. We wanted to get project owners a way to incentivize these certifications by UESI. We wanted to, you know, from a business standpoint, figure out a way to drive continued revenue to UESI so we can continue educational content and delivery of this rapidly progressing technology and practice field. We wanted to establish relationships with content developers like Texas Transportation Institute, you heard, and those delivering it. So, you know, again, it's a teamwork thing. And in order to make all of this work, we needed to establish some sort of certification board and, most importantly, certification criteria for some of these certifications that we're looking at. So we're going to start by looking at those areas within UESI that are relatively new, for which educational opportunities are somewhat limited outside of on-the-job training. One of those is the realm of utility investigations. And we looked at two different certifications in there, a subsurface utility designator, which is really a technologist level certification, and a utility investigation professional, which is that licensed function. We also wanted to look at this coordination pillar. And really there are, you know, we don't know yet how that's all going to shake out, because the term utility coordination means something different in every state that you practice. But we are honing in with some surveys and some outreach to look at, yes, there is that administrator, the technician level that looks and knows and coordinates and manages the different functions that are going on. But there's also a step above that, which is the technical specialist, the technologist who can actually know, hey, this is the constraints of a communication vault. It can only be this deep for this type of function. And therefore, if we're looking for space to accommodate that vault, they have the technical aspects to support the utility owner personnel at the same time. So let's look at that subsurface utility designator technologist function. Right now, there's a lot of 1 to 5 day courses available for training in how to respond to a one-call ticket for damage prevention using a pipe and cable locator. There's also several courses out there, whether it's 1 to 5 days for general GPR training. You know, this is how we use ground penetrating radar. There's several international efforts out there for utility investigating training, and we're going to look at one of those a little bit later. There's really no known US-based university courses in utility investigations other than the 40-hour short course that we first began teaching at Louisiana Tech's Trenchless Technology Center about 5 years ago, and is now, there are 5 universities around the country who want to take that up and regurgitate that training. And there's several, obviously more, subsurface utility engineering firms that have in-house programs, but quite frankly, out of all the ones I've looked at, they're largely deficient And frankly, they're based mostly upon one call training as the basis of that investigation. And the reason that's a problem is one call is very different than doing a complete utility investigation. And here are some of the differences. It's one call's a mark on the ground, and you don't even have to be that precise with it. Plus or minus 2 feet is good enough. So people don't pay a lot of attention when they're out there swinging their instrument around. They just want to get, hey, it's within the width of my shoulders or so, and I'm going to put a mark down. That's not good enough for a subsurface utility engineering investigation. We need to find unrecorded and abandoned facilities that are out there. They have just as much of a chance of causing a utility project delay problem as anything else. There's no searching for all utilities. It's kind of piecemeal. There's no traffic control, very rarely by a one call, to actually allow putting a transmitter where it needs to be over the utilities. And therefore, most of these one call companies mandate that their people only use conductive methods by inducing current onto a utility outside of the travel lanes. But that doesn't work. That only gives you part of the picture. There's no access to all the utility owner records for the site. You only have the records for the utility owner you're under contract for. Rarely do you open vaults, right? They're in the roadway. You can't do it with one person. You'll be dead. There's severe time limits to get your job done. Most states, it's 48 hours. You've got 48 hours from the time you're told to the time you have to mark a 5-mile project or even 2 blocks, 2 intersections. You can't get it done in that time frame. So you cut corners in quality. You don't have the right toolbox. You might have a pipe and cable locator, maybe 2, and that's it. But you need a lot more to do the job right. There's a lot of privately owned utilities that need to be addressed on these projects, but aren't by one call. Water and wastewater facilities are rarely addressed because they're municipal owned. DOT owns a lot of their own utilities now in the rights of way that they didn't used to, whether it's signage or traffic control or even collection of solar panels now in the traffic over ramp loops. And most importantly, there's no liability with one call in the design stage. So if you make a mistake or an error, whether it's negligent or not, there's no repercussions to get money clawed back to pay for redesign or project delay claims. So it's a lot different, and as such, the techniques and the methods and the rigor is completely different from one call to subsurface utility engineering. So what do we want a subsurface utility designator certification to signify? Well, we really want it to meet a particular performance goal, and that is certify the competence that this person can find every possible utility or utility-like structure within a project area through appropriate and available geophysics and document that position and the attributes that are there. And in order to do that, you've really got to understand geophysical theory, how specific geophysical tools work. You need to know enough about engineering survey to be able to document the location of these utilities that you have discovered the presence of. You need to have safety training in getting into those vaults and things like that. Most importantly, you need to know how all utility systems are designed and typically installed. So as you're getting secondhand information or information from your geophysics, which isn't a direct indication that the utility's there, it's an indirect measurement, but does it make sense to how utilities are actually designed and installed in the particular region or area of the country that you're practicing? And then, of course, identifying utility structures correctly and documenting them is an important part of that. So what kind of requirements meet that? Well, we're still trying to figure that out. Do you need a 2-year degree, a 4-year degree? How much experience? We certainly want to have some written testing, some field testing. We want to have an oral exam, just like you would to defend your thesis, for instance. There's going to be a host of potential courses that you could take, and maybe some would be required and some would be optional, but we want to see completion of those courses, and of course, keeping up with the times with continuing education. So we're looking at those kinds of elements for that certification requirement. The University of Hong Kong and some Asian universities and organizations have put together utility engineering and utility investigation courses that they're trying to promote worldwide. But I just wanted to throw this this particular screen up here to show you that they have different qualifications. A basic certificate is, hey, I took a 1-day training workshop. And a foundation certificate is, well, it's 2 or 3 days worth of a particular course, and there's a quiz. Now, do they have to pass the quiz? You know, that's unknown. It's not stated. And then there's a professional certificate, which says, okay, we need 84 hours of theory and practical and report and exam time to accomplish that. And they have to be a speaker or submit a paper. That's a wacky requirement, right? In order to get this diploma in utility investigations or utility survey and management, they call it there, they're looking at 270 hours of coursework. That's a lot. And if they go on to get that professional diploma, it's 400 hours. So you're really looking at a master's degree in a way, as far as the number of course hours that you would need. And maybe that's not out of line as necessary to meet that performance goal. So some of my thoughts on this designator certification is there's lots of programs and providers already in existence for one call. None of them completely cover our needs. Most of them deal with that damage prevention aspect. We need to incorporate and identify existing programs and use them, and we need to backfill those gaps with additional training, whether they're UESI short courses or online guided training or webinars or short courses put on at universities. And we can deliver that in a variety of different formats. The real sticking point is this field testing. You know, how do you test that? If you built a test site, you can never really mimic real world conditions with geophysics because of the long electromagnetic waves that we need and the amount of grounding of utility systems that if you just stick in a short section of pipe, you don't have that. But, you know, if you build a field test, then everybody has to travel to one location to get it. Well, that's an economic hardship. And who gets that advantage? So maybe it's more of a performance type field test where we say, here are the criteria that need to be met as far as utility complexity and types of utilities. And maybe if you had 2 intersections and someone were to go out and do an investigation and there was a method to check that investigation for quality, maybe because the project went to construction and they didn't have utility issues from undetected utilities. Maybe that's one way to do it. And of course, that oral exam. For the utility investigation professional, really, there's nothing like it out there. There's nothing that exists in there. And our goals in this is to fully understand and use ASCE 38 correctly, to know what responsible charge is. And quite frankly, as I do a lot of court cases and consulting around the country, I realize most professional engineers don't know what responsible charge is. I shouldn't say most. There's a significant amount of professional engineers that don't understand that. And so we need to know what it means for investigations and conflict resolution. We need to know how to develop and deliver responsible scopes of work and sequencing of investigation, iterations of this process through the project delivery process, and how those utility issues integrate with that project delivery process. So what are the requirements for that? Well, we kind of looked at, okay, you got to have a license, right? Now, the real issue is, do you need a PE license, a PLS license, or a PG license? And we've got to realize that utility investigations really melds aspects of all three of those professions together. And when you are melding aspects of three professions together, let's face it, usually the professional engineer trumps the other professions on a pecking order for a majority of that work. So yeah, we would prefer a PE license, but there are a few states out there, Florida, Ohio, North Carolina, that require a licensed surveyor to actually stamp any depicted utility work. So we have to be a little bit flexible with that. We need courses and experience in certain aspects: geophysics, engineering survey, utility system design and installation, deliverables, ASCE 38. And we have yet to determine the who, what, where, how, and when, and how many hours, and where these courses exist, and how are we going to get them, and what should the testing look like for all of that. So we have to develop some written testing for this. We have to develop some sort of criteria for an oral exam. We have to get examples of deliverables, and somebody has to look at them and say they're okay. And maybe there's a years of experience component to this, and maybe testimonials and references. So very similar to getting your PE license, or better, a better analogy would be getting your medical license and then getting a specialty in radiology or family practice, or whatever it might be. That, I think, is a better analogy. So we developed this graphic to kind of show that responsible charge aspect of utility investigations. And if you're going to stamp a utility deliverable from an investigation standpoint, you really need to be aware of and in charge of what I call the 6 M's of responsibility for a quality product. You got to know about the machines that are being used. How does a pipe and cable locator work? Was it calibrated correctly? What is the correct sequencing and frequency of calibration? How does a GPR work? Why does a time domain electromagnetic device make sense and a frequency domain electromagnetic device not make sense on this project? What about thermal imagery? You need to know how all of those machines work and how they apply to the problem. If you don't know that, you can't be in responsible charge. You don't need to be a machinist. You don't need to know how to take them apart and put them together and all of that, but you need to know how they fit into the picture that created the deliverable that you're trying to get out. You need to know about the materials that you're going to encounter. What effect does rebar have on a pipe and cable locator with high frequency? What effect does caliche soil have on ground penetrating radar? What effect does a rubber grommet cast iron or ductile iron joint have on the ability of a certain frequency to travel through that joint or across that joint, that gap in the joint of conductivity? All of that you have to know. You have to know about the methods employed on the project. How did I sweep the project to look for unknowns? What frequency did I start out with? How did I go about making a field sketch? All of those kinds of things. How did I survey it? You need to know about the effects of Mother Nature. What do I do when there's, hey, in Texas, I had a job going, but it's covered with snow. That doesn't happen very often, but it certainly happened last week. But it happens all the time in Minnesota and the north. utility investigations don't stop, and yet how can you do a thorough job if you can't see any valve boxes, handhole boxes, valve covers, manhole covers? It's very difficult to say I've done a complete job, and I'm going to stake my insurance on this project that I did a job, but yet there's snow on the ground or leaves or cars. Cars isn't so much a Mother Nature item. But the effects of COVID and social distancing may have had an effect. You have to know all of that. But most importantly, you have to know about the human that is out there. What are their qualifications? What's their mood today? You know, did their mother just die of COVID last week and their head's still not in the game? You better know that. You have to know their mood every day if you're going to be in responsible charge of taking their work and turning it into your work with your stamp. And then you need to know about the measurements that you're making. What are the accuracies and precisions needed for this particular job? And can I meet them with the machines and materials and the person working on all of that? So that's what responsible charge means. And every state has a statute that specifically spells out for engineers what that means. For instance, in Georgia, it says you must have daily communication with every person working for you every day. And you have to document that via written documentation, email trails, recorded conversations, something like that in order to meet that test. That's pretty onerous. It's the most onerous statute out there. I don't know what Arizona's statute specifically is, but I'm sure somebody will look it up here soon. So that's utility investigations. But then we have this other pillar, utility coordination. And we really think that there are two specific functions in there that could do well to have a training and certification process. One is the technician who knows and can facilitate the management of accommodation policies, kind of be the ether of the whole process and make sure it is all glued together, do the notifications, make sure the policies are known by everybody and that they're followed, and that the proper certifications to the federal government, that the state government complied with the federal accommodation policy and the codes of federal regulations, make sure all that's done. The technologist end of that coordination is more of the proactive design elements, where you're developing and suggesting actual design accommodation alternatives and their consequences, because quite frankly, utility owners rarely have the time to do that. And they're all working independently, trying to find space in the same most desired spot. So somebody can really take a cut at making this the most efficient for the public and the project owner by suggesting specific routes and understanding what is possible and what isn't possible, and all of the consequences of that from a cost and time and right-of-way procurement aspect. The Florida Utility Coordinating Council actually started a robust coordination training program in 2013, but they only ever got 4 of 6 modules completed, I believe, and they never have updated it since 2013. So it's kind of behind the times, but there is something to go on there. And of course, we have the Sharp 2 projects that Cesar worked on, and I worked on, and John worked on, that give us some background for that. And we have 50 different state DOTs out there that all have some sort of internal training, I hope, for some of these functions. And so I think we can beg, borrow, and steal from what's already available, and again, backfill it with specific courses. So some of the things that we needed to discuss and develop for this certification process is, how many certification boards? Do we have one board that has expertise in investigations and in coordination, or do we have subset boards? I don't know the answer to that yet. What are the qualifications to become a certification board member? How do we reach out to providers and owners and members and non-members of UESI? How do we develop and deliver content and testing for this? And if we are able to maybe utilize existing companies' internal programs and say, yes, you've got a good internal program, how are we going to audit that and know that they're following their program and they're not cheating with their own employee? And the big question for me is, does this fundamentally focus some of our utility risk management division priorities and tasks by having this certification process? I think it will, and I think it'll be a good thing. But that's our first cut at a certification program or accreditation program for the specific skill sets that the engineering team involved in utility investigations and utility coordination need, we believe, at this point. Still very much in flux. So I'm going to shift gears now and go to the ASCE 38 revision. Yes, it's really coming, and it's soon. Its current status is that the standard has unanimously passed its first hurdle, which was a full committee ballot. There were quite a few wordsmithing suggestions and a few additions or new ways of explaining things that are going to require a second committee ballot, which is being prepared now. I don't anticipate a third committee ballot. So then after the second committee ballot, the draft goes to ASCE publications to make sure all the copyrights are in order, get it ready for public balloting by doing a light edit. And after that, the standard enters a public ballot period for 45 days. We take all of the comments coming in and address them. And if any of them require us to make a substantive change to the draft for the better, we have to reballot the committee for that. And if all of the public comments are editorial and non-persuasive, we electronically process that in accordance with Library of Congress rules, and it gets published. And I expect that to happen this year. The 2002 version was relatively short, 20 pages. It had some definitions, tasks for the engineer and project owner. It set forth the concepts of utility quality levels and how to get to them, some basic examples of deliverables formatting, and it had a chapter on return on investment studies, an appendix for surface geophysical methods. The standard was really very basic and written in terms that after the fact, we realized were quite open to interpretations. And to a degree, that was intentional, as all of these concepts were new to the engineering world, and a lot of innovation and different ways to get to that preferred place were contemplated. What we didn't expect was for so many people and organizations to take things so out of context, like clipping a definition from several sentences long to just 3 words. And those 3 words changed the entire meaning of what that definition was. Or somebody read an article somewhere or attended a PowerPoint presentation like this and said, oh, I now understand everything about ASCE 38. I attended a seminar on it. And they never even read the standard itself. We also didn't realize how much impact the relatively new contract locating industry would have on interpretation, especially when the missions are different and taken out of context. The fiber optic boom and bust left a lot of vacuum excavation rigs that were built for HD exposure of utilities needing to find a purpose. So the contracting locating industry teamed up with all of these excess contractor rigs in the HDD world, and they called it SUE, because they had a vacuum machine and a pipe and cable locator. And they thought, that's what this is. That's all it is. And because people thought they were performing subsurface utility engineering, they also thought they were engineers. And so if you look in the phone book in Cincinnati, Ohio, There are something like, Paul Scott told me, 130 firms that say they practice subsurface utility engineering. And if you look, it's every electrical and plumbing contractor in the city has decided for some reason that they're an engineer because they have a vacuum truck or can lease one, and they have a pipe and cable locator, or they can lease one and they're now an engineer. So a lot has changed since 2002. It's taken a while for the practice to catch up with the standard, and the evolution of the practice combined with technology, new technology, makes it certainly past due for an updated version. The concepts remain the same because they were solid, but there are many little changes that will make this standard better. One such change is the title. We're going to change the title to be a little bit more descriptive, and it's going to be standard guideline for investigating and documenting existing utilities. I mean, that's really what we're doing. We're not just collecting information, we're investigating what's out there. And we're not just depicting them, we're documenting what is, or depicting or mapping, we're documenting attributes of that kind of utility and other aspects of those utilities, not only for the subsurface, but for the connected aerial facilities that make up the system of systems of utility networks out there. So we think the title is more descriptive and apt. You know, we do change collect to investigate. We change depict to document, and we change subsurface utilities to basically all utilities. So it's also, we want to recognize that this is, as EJCDC contract lawyers say, this is an engineering, planning, report phase, and design task. We're not doing this for the benefit of the utility owners to have a better utility record. It is, in fact, part of the design. The investigation and documentation of utilities becomes part of the design drawing. So the new ASCE 38 looks like it may be closer to 200 pages rather than 30, although I believe there will be hard copies available and certainly PDFs. The graphics may not be in color, so printing the PDF version may be preferable. If someone says now, I want a quality level B survey, we've seen a lot of people interpret that to mean only utilities that were able to be designated were depicted or documented. And we've had clients ask for a quality level A survey, and rather than telling them that that would mean wholesale excavation of the site, someone did something for them without that explanation, and the client's expectations were unfulfilled, and they didn't use subsurface utility engineering again. That previous version of ASCE 38, the 02 version, was quite basic, with the mistaken belief that professionals would strive for more than the absolute minimalistic, out of context interpretation of what the standard said. And I was wrong, because most people did twist it. So this version is going to fix that by having a lot more context in the form of commentary and graphic examples displaying how different situations may impact judgment on whether something has achieved quality level B or C or even A. So there's going to be some performance goals that are stated in the standard. They were always intended to be part of the ASCE 38 standard, but now we've made it very clear that we say that this standard provides guidance on performing and depicting utility investigations to assist the project designer in addressing two questions. One, how can I design this project so there are minimal utility issues during that entire project development process? And two, how can I protect myself against utility related claims anywhere in that project development process that might happen? If we can achieve those performances through the use of this standard, we're golden, and that's the intent of the standard. But we also want to say that ASCE 38 is a combination of both a prescriptive standard and a performance standard. So as a prescriptive standard, it sets forth a series of minimum actions you must do to attempt to achieve a particular utility quality level. You may not achieve it, but you have to do these things to attempt to achieve it. And as a performance standard, it describes that significant professional judgment that should be exercised by the professional to determine when am I going to do it, what is the sequencing? We had a question about that earlier with Cesar, right? What's the sequencing of construction, and should the design engineer be responsible? Yes. And what is the location of the utility investigative effort to achieve that goal, those performance goals? Knowing this uncertainty, and it is all about uncertainty, the utility quality level, that's another major shift is we're recouching that. We're going to keep the term the same. It is a utility quality level, but those quality levels represent relative unquantifiable uncertainty as to whether it exists and it is where we say it is. And so knowing that uncertainty allows engineers to make better risk-based decisions regarding where they're going to place a design element, or what kind of design element they're going to place, and what it's going to cost, how long maybe to relocate a utility if they decide that that's their best option, and public safety issues. So what's the same? Well, we still have definition of terms, although we've changed some of those definitions to be more succinct. We still have 4 quality levels, A, B, C, and D, and we still give examples of different ways to depict and document utilities on that utility drawing. Part of that documentation is a listing of attributes for a utility, such as type, size, number of cables, ownership, encasement, active, out of service, etc. And we tried to harmonize that with the new ASCE UESI as installed utility standard, the as-built standard, so to speak, so that these attributes are fairly concrete and well defined. We still have a section on what the engineer should do and what the project owner should do. And although we still have a section for return on investment studies, going back to that question, is 1% a good cost of construction? Well, we moved that data that we have to an appendix rather than in the body of the standard, because it really has nothing to do with what should the engineer do. It's just information. And we still have that appendix on near surface geophysical methods applicable to identifying and tracing underground utilities. What's different? Well, we've got those specific performance goals. We're including aerial utilities in the definition and deliverables and examples. We have some new and revised definitions. We have new survey accuracies for quality level C, B, and A that didn't exist before. We have lots of commentary. We have a section on vaults. We have a section on other structures like thrust blocks when known. We talk about some of the new geophysical methods that are out there. We talk about depths as part of a deliverable, and 3D models as part of a deliverable. And as we mentioned earlier, a utility report. And if we keep in mind that the users of these deliverables, which could be design engineers or CAD technicians or utility owners, they may know nothing about utilities or other utilities other than their own. And our job in using ASCE 38 is to give them all the information they need to make good design decisions, taking into account constructability and what it is they're designing. So let's look at vaults. And I just put a graphic together. This is an actual project in Washington State, the Alaska Way Viaduct project, pretty big downtown. And, many times the symbol for a vault or manhole cover, we pull it out of the CAD library, right? We slap it down on the plans. Here's the manhole cover. It really doesn't reflect what's going on under the ground. It doesn't tell us anything about the shape, position, or orientation or extent of the underground space that's being used, and it may not be directly over a symmetrical space. So this is the actual plan set, and you can see on the plan set where there are some manhole covers and vault covers, but in reality, this is the space that's taken up with those vaults. And, on this project, we actually showed those spaces being taken up by the vaults. You can't do anything where there's a vault. You can't drill another utility through it. You maybe can go under it. You can go beside it. But it takes up a lot of space, and really the utility structures in this case are just as important as the utility segments in determining what's available. Here's another a little example of that. In plan view, the electric vault looks like this. You have two manhole covers, access covers. They're not over the center of the vault. You've got some ducts coming in and going out. And on the right-hand side, you can actually see a LiDAR depiction of that, a survey of that, showing how it fits in a 3D space and what is going on inside of that vault as far as structures and number of cables. So I'd like to talk a little bit about this this graphic. We start with data from the client or the project, as Cesar talked about. We start with that data, and we have inputs, and we get inputs from various sources. We can see a utility, we can see a utility structure, we can get geophysical data, we can get records, and we filter all of that through a scope of work and our professional judgment, and it all goes through that professional, that licensed professional, who then prepares the outputs from all of those inputs. And those outputs are what was achieved as far as the utility quality level, with increasing certainty as we go from D to A. And all of that again gets filtered through what did the scope of work say we're going to do, and what's our professional judgment, and ends up being the utility drawing and utility report deliverables. I want to mention real quick one more publication that was published, Subsurface Utility Engineering for Municipalities. We misnamed that. It really should say for public agencies, because it really works just as well for state DOTs or federal agencies. And it sets forth a template for a scope of work to say, what are you going to do? And ASCE 38 says how you're going to do it, but this document says what we're going to do and what pre-qualifications are. So with that, I am going to, if we have any time left, open it up for some questions.
Actually have a couple of questions. Sorry, we're going a little bit over, guys, but I want to make sure your questions get answered. The certification, cover, investigation, and coordination with utilities that you presented on, are those primarily on private land or quasi-private areas, and where utility information may be poorly managed?
Our intent was to make it for any land owned by a public agency, private agency, whether it's a hospital campus or a military base or a private land development, it doesn't matter. We wanted that to be all encompassing.
Great. What form would you deliverables would be for this type of certified professional to either clients or DOT?
What form? Well, it would probably be, if I'm interpreting the question correctly, there would be more initials after your name and PE license, whether that is CUIP, Certified Utility Investigation Professional. We don't quite know yet what makes the most sense from an endorsement standpoint, but we think that that's what the form will take. Just like we have LEEDS AP and other IRWA initials that go after the names of some of the speakers here today, we would have more initials for those certifications, whether they be the technician, technologist, or professional.
I also could see that, Jim, is just chiming in on that one, is what other deliverables? There's CAD files, there's the utility investigation plan sheets, the utility reports, all those type of things, right?
Yeah.
That person would certify.
That's right. And we haven't come up with that comprehensive list yet, but it's certainly our plan to do so.
In Arizona, part of our coordinating utilities is contacting 811 blue staking, and then they contact all the utilities within the project limits, and those utilities, they'll come and mark up their utilities. Survey crew then picks those utility marks and collect as-built, utility maps, quarter sections, all those kinds of things. During the construction, the contractor contacts the utilities again to mark their lines. Does any of that consider UESI coordination or these types of certifications?
Well, that's a big philosophical statement. First of all, you know, the 811 system is just one phone call. It's an answering machine, an answering service. So all that does is notify, hopefully, all of the utilities. But we all know that there are utilities out there that won't respond to that, or don't know they have facilities, or there's private utilities, whether it's a hospital's oxygen line, which is pretty darn important. You don't want to cut that. Or maybe a nuclear waste line in one of our Department of Energy sites. You know, it's a process that yes, it may be followed on some projects in Arizona, but it's not complete. And what we want to do is create a process that works for any and all projects and is complete and most efficient, and actually encompasses good practices to accomplish those goals of minimal utility issues during project development. And quite frankly, I think Arizona's procedures could use some cinching up, but
well, Jim, and I'll follow up a little bit on that one with regard to, you know, when people call out, you know, 811, you know, 811, the blue stake comes out, it's the last ditch effort. It's not a design activity, it's a construction activity. And it was put in place to be the last ditch effort to protect that utility prior to construction. So by law, somebody has to mark in the field if they use equipment or they don't use equipment. You know, they go out in the field and they'll go off of a record if it's non-tonable or they don't have the proper tools to go into to actually mark that utility. They have to actually mark it no matter what. So what it does is, you know, we're talking a lot with the ASCE 38. It's uncertainty, so it's removing the uncertainty of those utilities. So everybody who typically in the past, and you know, that's one of those last century engineering practices of what you just kind of had mentioned, Stephanie. But what it is it's giving an engineer a very cozy feeling that a 811 went out in the field and located it, and their survey team picked it up. But you as the engineer, you're feeling at that point, oh well, 811 marked it, so you know, you feel all great about it. But in reality, you don't know if they used records only, if they actually used equipment. You don't know what the technician was on that day, if he's even certified or qualified, you know, or how accurate his information is. And on top of that, you got 5 or 6 different companies who go out and mark, say, one intersection. So what you end up getting is a lot of unknown data and a lot of uncertainty in what they've actually produced for you. I know, for instance, I've been out in the field and I've watched an 811 representative walking down the side of the street painting blue paint, and we asked him, what is he doing? And he said he's blue staking the water line. He didn't even have a piece of equipment with him. He had his arm stretched out to the middle of the road and he was walking down the road painting the roadway. But it was because he said, well, I know that in reality this line is 8 foot from the center line, and this is where my location is, and I'm close enough as it was. The bucket found that water line and it was off, and it, you know, hit a 16-inch main. So that is a last century engineering practice, and that's what the ASCE 38 was developed for, is to take the uncertainty of the utility data that you're looking at and making it certain of how accurate the depictions are and how good the information is. So as a utility team member, an owner, a contractor, a design team, everybody is up to this, you know, on the same page of how good the information and what depictions of each utility is. So a contractor can look at it and understand the liability that sits with each individual utility. then he could reduce cost. A design engineer can change a design, mitigate his design to best cost effective solution for the team. Overall, that's probably the hardest thing you can look at, because that is definitely a last century engineering practice that kind of highlighted by utilizing 811. They painted on the ground, and I will say a lot of times by law they don't have to paint on the ground unless it's for construction. So there's a lot of uncertainty in that as well. Did everybody go out there? Did they mark? Who investigated it?
Here's one thing that I think harkens back to one of the 6 pillars, which is, that utility construction phase, which is where blue stake damage prevention takes place. But it would be really good for those blue stake markers, locators, to have a set of up-to-date utility plans that were performed by and stamped by a subsurface utility engineering investigation, and use that to help them in their job. Additionally, it would really benefit project owners on large projects, that is, to retain the subsurface utility engineering consultant through construction and serve as that interface, kind of a construction inspector for the one call marks, to say, hey, this isn't what we found before. Let's dig into this, no pun intended, let's dig into this conflicting data, the mark on the ground and what we show on the plans, and try to resolve it before it causes a construction delay and a claim. And that's something that not very few project owners are doing. And I think it should be a routine event for projects of a certain complexity and size.
Is there an ASCE number for the?
A number? No,
Yeah.
there's no number. It's just subsurface utility engineering for municipalities. You can find it in the ASCE bookstore very easily, just by typing in subsurface utility engineering, probably.
Oh,
I didn't catch that. You were bouncing back around.
also find the
couldn't hear the
ASCE
question.
38 standard. Can you also find the ASCE 38 standard at the bookstore on ASCE website?
Yes, you can find the 3802 version. You can't find the new version yet because it hasn't been published. But check back in September-ish.
All right, that looks. Thank you guys so very much for your presentation. If anybody else has any further questions, you can definitely email them to me and I will forward them on and try and get you an answer back. Thanks so much, everyone, for joining.
Thank you.
Thank you, Stephanie. Appreciate it.
Thank you.
Thank you, everybody.
Have a great rest of your day.